Hello everyone, welcome to Satya. Now we are here at the second part of Parabola. Before watching this video, please check the previous part of Parabola. In that video, we have discussed about the basic formulas of Parabola and so on. Please check that. And now, in this chapter, today we are going to discuss about tangents and normals of a parabola. First of all, let's discuss about tangents. First of all, let's draw a parabola of equation y square equals to 4ax, and see here, what is a tangent? Tangent is a line touching the curve only at one point. For example, this is a tangent, right? This is the only point that touches the graph y square equals to 4x or the curve. See here, the y-axis is also a tangent to the curve y square equals to 4x. Okay, now for finding this equation or else finding the equation of tangent, the formula is replace the value of, first of all let's assume that this point is P and the coordinates are x1 comma y1. Okay, and here for finding the tangent I am going to replace y square as y into y1 and 2x as x plus x1. We have discussed this kind of transformation in finding tangents for circles also. You can check there also. Okay, now the equation will become y1 is equals to 2a into x plus x1. This is one way of representation of tangent to the curve y square equals to 4x. Now we can also say in the parametric form, which is, now I am going to take this 2a to here. y1 by 2a is equals to, y by 2a is equals to x plus x1 by y. So that I can get a form of y equals to mx plus c. So here y by 2a is equals to x by y1 plus x1 by y1. See, this is a constant, and see here this is y equals to mx plus c. We can bring 2a to that side also. Y equals to 2a into x by y1 plus x1 by y1. See here, x1 and y1 are the coordinates which are constants and y and x are variables. So now from here we can say that 2a by y1 is equals to m, which is a slope of the curve which is tangent to the curve y square equals to 4x. Okay, I will create some space. See here, at last we got the value of m as 2a by y1, and from here we can write y1 equals to 2a by m, and here this equation is known as slope form of a tangent, point form of a tangent. This is point form, and there is a parametric form of tangent to parabola and slope form also, which we will discuss. Now I am deriving slope form from point form. Okay, from here only, right, we got y equals to 2ax by y1 plus x1 by y1, where this is in the form of y equals to mx plus c, and here the value of m is 2a by m, y is 2a by m. Now as this point y1 is passing through the curve, we can put the value y1 in the equation. So y1 square, which is 2a by m whole square, is equals to 4ax x1. Okay, now 4a square by m square is equals to 4ax, 4 gets cancelled and a gets cancelled, and finally the value of x1 is a by m square. So now what we got, any point on the curve must be in the form of a by m square comma 2a by m, for which it is a point of contact of the line and the curve. So this point P may be a by m square comma 2a by m, where m is the slope of the line. Okay, this is known as slope form. This is slope form, this is point form, the next is parametric form. In the first part, we have discussed about the parametric representation of a parabola, which is 80 square comma 280. Okay, these are the points on a parabola which is in the parametric form. Now, for finding tangent of parametric form, simply put the values in the equation y1 equals to 2a into x plus x1. Putting the parametric values of the parabola in the point form. See how what we will get, y into y1 into y is 280, right? 280 is equals to 2a into x plus 80 square. And after further calculation, we'll get the equation. Simply cancel the 2a, and here we left with y1t is equals to x plus 80 square. Okay, this is only for y square equals to 4ax. As I said in the first part, for y square equals to minus 4ax, just represent the value of a as minus a. And similarly for x square equals to 4ay, replace the values of x and y. Okay? And now here, this is a slope form, right? For finding the equation, we can get, now for finding the slope form of tangent y square equals to 4x, this is not the completed part. They have to find the equation of the tangent. For this, simply put the values of p in point form. See, every derivation requires this point form. As we have observed, the slope form requires the point form, and parametric form also requires the point form. So, only just replacing the value of y square as y1 and 2x as xx1, this formula became a major one. Okay, now put these values. Y into a by m square is equals to 2a into x plus, this is y, right? Y is 2a by m, okay, y into 2a by m is equals to 2a into x plus a by m square. Now here we can cancel 2a and 2a. Y by m is equals to x plus a by m square. Simply send this m value to RHS and we will get y is equals to mx plus a by m. See here whether this equation is in the form of y equals to mx plus c or not, which is the equation of line. If this is c, which is a constant, and m is the slope, so the condition for a line must be tangent of a parabola y square equals to 4ax is the constant c value must be is equals to a by m. Remember, this is only for y square equals to 4ax only, and x square equals to 4ay and x square equals to minus 4ay, y square equals to minus 4x, they are completely different. Okay? So here, this is the equation and this is the tangent to y square equals to 4ax, which passes from the point a by m square comma to a by m. Please note it down, this is very important. And please try to solve or else derive the formula for y square equals to minus 4ax and x square equals to minus 4ay and x square equals to 4ay by yourself, so that it will improve your skills for finding the formulas. And now let's discuss the angle between tangents of a parabola. Angle between tangents okay, this is a parabola, and let us assume a point P here, and there passes two tangents here. Okay, these are two tangents passing from point P to the parabola y square equals to 4ax. Now we have to find this angle. Let us mark this angle as theta, and I will simply use a formula. It is an easy formula which you can remember easily. Tan theta is, as you all know that tan theta is m1 minus m2 by 1 plus m1 m2. It is a general formula, m1 minus m2 by 1 plus m1 m2. As m1 is the slope of, let's take this as y equals to m1x plus c, and this tangent as y equals to m2x plus c. These are the two equations of the tangents, and m1 is the slope of first tangent and m2 is the slope of second tangent, and the final result will be root of s11 by x1 plus a. Okay, easy to remember, right? Tan theta is equals to root of s11 by x1 plus a. As I said in the circles, s11 is nothing but the equation of the parabola, putting the y as y1 and x as x1, which you will get as y1 square minus 4ax1 by x1 plus a. Okay, this is the value of tan theta. It is angle between tangents. Hope you got it. Next, let's discuss about normals of a parabola. First is normal. This is a parabola. And let's take, this is the tangent, and we all know that normal is perpendicular to the tangent. So this is the normal for the parabola y square equals to 4ax. For deriving first of all, let's derive the point form. We all know that point form is very important, right? From the tangents also, we learned how important point form is. First of all, let's derive the point form. Let's take this as x1, y1. What we have got from the point form of the tangent of the parabola, the points are, see, we have to like this, right? M as 2a by y1. Got? Okay. Now y1 will be 2a by m. But here, as this is perpendicular, as the tangent is perpendicular to the normal, we will get m1 into m2 as minus 1. So here, what will this equation will become? M into m dash equals to minus 1. So here m dash will become as minus 1 by m. So in the place of m, I am going to put minus 1 by m, which is y1 equals to minus 2am. This is the expression for y1, that is a point, the y coordinate of a point on the parabola y square equals to 4ax. Now, see here, don't confuse. Here m means the slope of the normal, not the slope of the tangent, okay? Now, for finding the x value, put the value of y1 in the equation. 2am whole square is equals to 4ax, right? 4a square m square is equals to 4ax. 4a gets cancelled and x is am square. This is the value of x1. Now, the value will become as am square comma minus 2am. This is the point on the parabola. And the point form will become as y minus y1 is equals to m. What is m here? M is minus y1 by 2a. So, minus y1 by 2a into x minus x1. This is the point form of the normal of the parabola. And similarly, the parametric form, the parametric points are 80 square comma 280, right? Put the values here. So we will get the parametric form of a normal to the parabola. Next, let's see a slope form. Slope form is very important. Let's derive it. Next is slope form. As we discussed the tangent, everything will be derived from the point form. Same in the normal also, everything will be derived from the point form, okay? Now, first of all, expand that point form. Y minus y1 equals to minus y1 by 2a into x plus y1 x1 by 2a. Now here, simply put the values of x1, y1, which is am square and minus 2am in this equation. Y1 minus, what is the value? Y1 as 2am. So, is equals to minus y1 is 2am x by 2a plus here am square into minus 2am by 2a. So do the cancellations. 2a gets cancelled, and here also 2a gets cancelled. Y is equals to mx plus minus 2am. I brought this 2am to RHS. Y equals to mx minus 2am plus, plus or minus, here, minus am square into m, which is am cube. So, this is the equation of normal to y square equals to 4ax, y is equals to mx minus 2am minus am cube, and passes through am square comma minus 2am. This is only for normal, remember that point. Normal, and that too for only y square equals to 4ax only. It is different for y square equals to minus 4x, x square equals to 4ay, and that all. Please try to do that. Try to derive the formulas for normal of x square equals to 4ay and the remaining two parabolas, okay? They are not same. Please do note it. That's it for today. Please like, share and subscribe to this channel. If there are any comments or suggestions, please drop them in the comment box. Thank you.